Good day, everybody. We are from Group 1 and want to present about solar-based solar power. My name Hafidz and my other groupmate is Aideel, Naim, Nadzir, Izzamuddin and Farha. What is space-based solar power? Basically, it is a large structure sitting in space that converts the solar energy into a form of energy. Then it transmits the energy wirelessly to a remote receiver station on Earth. Before we dive deep into the topic, let's look at where the idea originates. In 1941, Isaac Asimov, a writer that published Reason, a science fiction story about space station transmitting energy from the sun to the planet using a microwave beam. Then, in 1973, Peter Glaser patented his method of transmitting power over a long distance using microwave from large antenna on satellite to rectangle, much larger one on the ground. Between 1978 until 1986, the Department of Energy and NASA jointly organized the Satellite Power System Concept Development and Evaluation Program. But in 1997, Pete Worden claimed that space-based solar is costly with a major cost to transport material to orbit, which will not be available for decades at the earliest. China proposed collaboration with India for both can work for long term to bring space solar power to Earth in 2012. In 2014, Japan Aerospace Exploration Agency announced that the solar space base will become reality within 25 years.
Let's move to the design criteria. SBSP still in research for NASA and Department of Energy. Space-based solar power consists of three elements. First, solar cell. Solar cell will use for collecting solar energy in space with reflectors for thermal system. Wireless power transmission will transmit the energy to Earth since it's outer space via microwave or laser. Plus, a rectangle will be used for receiving power on Earth. There are four system types of space-based solar power, which are microwave power transmission, laser power beaming, orbital location, and Earth-based receiver. Microwave transmitting satellites orbit Earth in geostationary orbit about 35,000 km above Earth's surface. Designed for microwave transmitting satellites are massive, with solar reflectors spanning up to 3 km and weighing over 80,000 metric tons. They would be capable of generating multiple gigawatts of power, enough to power a major US city. Laser transmitting satellite in low Earth orbit about 400 km above the Earth's surface, weighing in 10 metric tons. This satellite is a fraction of the weight of its microwave counterpart. This design is cheaper too, but it would cost nearly 500 million to launch and operate. The beam will only be about 2 meters in diameter instead of several kilometers. At its smaller size, there is a correspondingly lower capacity of about 1 to 10 megawatts per satellite. SBSP can generate 2,000 gigawatt power constantly. Experimental site area is 2 hectares, surrounded by a clearance zone 5 times larger. It will get 24 hours of sun energy. The planning for base-based solar power plant, Japan 1 gigawatt system in 2030. China will build a satellite 100 kilowatt satellite in low Earth orbit in 2025. 1 megawatt satellite in geostationary Earth orbit in 2035 and 1 megawatt station base in 2030. The construction cost estimate for partnership is $100 million. The comparison between space solar versus conventional solar is the space solar can withstand the extreme conditions such as excessive heat and cold, constant shower of solar radiation. Meanwhile, conventional solar cannot withstand extreme conditions. Then, conventional solar need to convert from DC to AC signal. Meanwhile, space solar do not need to convert to AC signal because in space electricity do not travel and can stay in DC format.
Is a grid-connected system. The space-based solar power has antenna on the Earth ground to receive the power that is transmitted from satellite. Then the power transfer to grid utility. It is a grid-connected system.
Good day everyone. So today I want to talk about how space solar power work. So the first thing we need to know is the component. So the first component is the sun. So the sun is used to supply the sun energy. So this energy can be converted into the electricity. So the second component we have SPS alpha space-based harvesting, or we can call it as space solar panel. This space solar panel will process the solar energy into the electricity, and then from the satellite we can transmit the energy into the earth by using the third component, which is we call it as microwave. This microwave is known as electromagnetic wave, so it will transmit the energy from the space into the earth. So the next component is ground station. So the ground station is used to receive the energy from the space, and then the energy will be processed and transferred into the local power grid, and which is the next component. So from grid station, they process the energy and then transfer it into the last component, which is user. So let's talk about how space solar power work. So the SSP includes systems to collect, convert, transmit, receive, and distribute energy from the sun. Solar power satellites are designed to collect the sun energy with large solar array. The amount of energy that can be collected is determined by the size of the solar panel, the location in Earth orbit, and the efficiency of the solar cell. So the satellite also contains the necessary equipment to convert the sunlight into electricity, and then it will be transmitted wirelessly to the receiving antenna on Earth. The electricity needs to be delivered from the satellite in space to the ground without using wires. So wireless power transmission, WPT, enables the transfer of energy from one location to another by using electromagnetic wave. So this is a perfect solution for transmitting the energy from space or in any circumstance where power lines won't work, such as very rough terrain or to moving vehicle or system. The effectiveness of the end-to-end energy transmissions depend on many factors, which is the equipment used, the power transmitted, the distance between the transmitting antenna in space and the receiving antenna on the ground, the size of each antenna, and the wavelength of the EM wave used between them. The receiving antenna captures the arriving EM wave and convert them into electricity. The electricity is then processed and delivered to the local power grid, and from power grid, they will transfer to the user.
And next, we will diving into the specific applications of space-based solar power. What is the load of this photovoltaic system? Space-based solar power is implemented with spacecrafts operating in the inner solar system, whilst relying on the use of photovoltaic solar panels to derive electricity from sunlight. Dominantly, the application is used on solar power satellites. When the sun shines on these panels, they would absorb bundles of direct current energy. That energy would get translated into radio frequencies, and accordingly, the power would be brought down to Earth. That would happen through microwave radiation. Radio frequency energy would be beamed toward our planet onto areas reminiscent of solar fields in the desert. But in place of what are typically solar panels, these regions would contain receivers with antennas that collect the harvested energy. It is basically wireless energy transfer, something Nikola Tesla famously alluded to in the late 19th century. Using such radiation allows the system to operate in rain and fog, at night and during gentle storms, only risking disruption by more severe weather. However, one question often raised about wireless radiation patterns is whether they would adversely impact vegetation or features of the land. Fortunately, the power density received on Earth would be equivalent to the power density in sunlight on a sunny day, and systems for space solar power can be designed to be intrinsically safe in this regard. As an extra safety precaution, familiar measures can be taken, like cordoning off the receiver zone. Cell phone towers, which use a similar form of wave communication, do the same. After the Earth planted receivers retrieved the energy in the form of radio frequencies, they would work with a ground station to convert it back to the DC energy, which would then be transformed into alternating current power fed into the utility grid. It is a complex process, but that last bit, the AC power, is the regular old electricity that runs through your house's sockets to charge your phones and give life to your laptop.
So moving on to the next part of the discussion, which is the impacts on society regarding the use of space-based solar power (SBSP). The impacts actually consider two factors, which is the first factors is health factors and the second factors is the economic factors. Okay. So for the health factors, it is obvious that we can avoid pollutions because of the use of the renewable energy. Because when we use non-renewable energy, some of the procedures causes a side effect that pollutes the environment. Some of the procedures produces harmful gases and waste that can pollute the environment. So by using SBSP, which use the solar energy, which is the renewable energy, we can avoid those circumstances because, as we know, the method does not produces any side effects that can pollute the environment. So when the environment is safe, when the environment is not polluted, then the society can live more healthier rather than when the non-renewable energy is being used. For the second factors, which is the economic factors, the economic factors consist of cost and land usage. So for cost, as mentioned previously on the disadvantage of using this approach, the cost related to this approach is very expensive. This cost includes the launching satellite cost, the materials to build cost, and more. Moreover, the system also needs maintenance and monitoring from time to time, which also very costly. They need to go to space and reach the panels every time the panels need any changes or any maintenance, which is costly in terms of transportation for both astronauts and materials needed for maintenance. However, by using this approach, we can also replace the available space that meant for solar panels with other facilities or business. So with this, electricity and power can be generated without having the solar panels occupying the space. that can be used for other facilities or business to be built and grow in order to raise the economics.
Next, the main advantages of space-based solar power (SBSP) are the cleanliness of energy collection and generation, the amount of energy provided by such a system, and in terms of aesthetic. One of the primary advantages of space-based solar power is that it is one of the cleanest type of energy available. The sun is the primary energy source for the earth. Solar energy harvested directly from the sun's ray can be seen as the cleanest and the most efficient form of energy production, since all energy the earth receives come ultimately from the sun directly. Next is for the in terms of aesthetic, beauty in the eyes of the beholder, but in some case the beholder may still want to divert their gaze. Oil rigs, solar panel on roof, windmills, coal-fired power plants, and the other way to convert natural resource to electricity all fall into this category. On the other hand, space-based solar power does not damage the Earth's natural landscape. Satellites orbit the Earth at a long distance, approximately 35,000 kilometers, while power collection facilities should be located in remote, barren, and relatively quiet areas to minimize human, animal, and vegetable interaction with electromagnetic wave emitted from a geostationary satellite. Next is disadvantages of the system. While there are many reasons to support the modern implementation of space-based solar power (SBSP), some weaknesses in this concept remain. The biggest obstacle to SBSP are excessive launch costs and safety hazard. Given that a 20-foot by 20-foot solar panel weighs about 3 pounds per square foot, the launch cost for a solar panel of the size and weight is $1.56 million. In addition to the cost associated with the launch of solar panel is satellite maintenance. The satellite does not operate indefinitely, and maintenance costs are likely to be proportional to the cost launch, since the operation company may need to send their technician to the satellite itself. Next, safety hazards include misdirection of the satellite's energy transmission beam, which could cause damage if not oriented properly, mistake during the rocket launches, and long-term effect of low-frequency EM radiation. Emergency scenario may take place over the lifetime of SBSP system that is nearly impossible to predict in advance. Some safety hazards may not present themselves until the SBSP system is in operation.
In conclusion, SBSP has its own advantages, for example, efficient in receiving and collecting solar energy due to its position, and disadvantages such as high cost in mostly everything related to it and safety of the astronauts. The initiative has been discontinued in 1980 due to little knowledge about technical, economic, and environmental aspects and research, which leads to high-risk venture. However, space-based solar power has enormous potential for future energy generation. Although SBSP is not economically viable at this time, many of the disadvantages and flaws of such a program will diminish or disappear completely over time.